Yeah. So that's one special type of diode that do exist. It's referred as a Zener. This one, the next one is called as a Varactor diode. So you see the symbol of this diode is it's like a diode symbol, but what do you think what is this? Right? So it's a capacitor. So the purpose of this diode is it will change the capacitance across the terminals of the diode if you change the voltage. So it can change. So Varactor diode, it's used to change the value of capacitance by controlling the voltage. So it's also referred as voltage controlled capacitor. Its intended region of operation is always in reverse bias. Yes. The only purpose of Varactor diode is to control the capacitance by changing the voltage, but its operating bias method is always reverse bias. So this is the symbol for it, like you draw this triangle like you draw for diode, and just put a capacitor. Instead of one line, you put another line that indicates that's the capacitor. So that's the indication that it's a Varactor diode. Oh, that's an epsilon. No. All right. So in order to know the behavior, I will come back to that in a minute. The behavior of this diode, again, when we use a reverse bias, so we need to talk about like what really happens in a normal diode in reverse bias. Let's say, for example, you have this P-type, N-type material. P is mostly positive, correct? Remember that majority is positive. N means that's an N-type, the majority is negative, correct? So reverse bias means, so we take the P-type and wire it to the negative, N-type to the positive, correct? So what will happen when we do this? So what will happen when you have a P-N junction in the reverse bias? Specifically, what happens to the depletion region? If I increase this reverse voltage, what happens to the depletion region? Right? So remember that you are now in the reverse bias, meaning that all these positives will be attracted towards the negative side of the battery. All the negatives will be attracted towards the. So that means the depletion region will keep on increasing it. This is the key aspect of a Varactor diode. So how come widening a depletion region or reducing the depletion region will cause for a change in capacitance? In order to know that, you need to remember what is meant by a capacitor. What is capacitor really is. Yeah, not the application of a capacitor, but what is really, how to form a capacitor. So you require two plates, correct? That's of course the symbol of a capacitor. So you have two separate plates. These two plates are conductors. But what should be in between these two conductors? A non-conductor, which is usually a dielectric material or an insulator. So depending upon how far these two plates are, meaning that these two plates are separated by a distance. So the formula for capacitance in its physical characteristic is C is equals to epsilon this is the nature of that insulating material, which is usually called as dielectric constant. A is the area of cross section, but most importantly, the D is the distance between the plates of a capacitor. So how far these two plates are separated. So that means if you increase the distance between the plates, what will happen to the capacitance? So if I increase this distance, what happened to the capacitance? The capacitance will goes down because there is a more separation between the plates. So Varactor diode will take this pretty much into account. So when you're widening the depletion region, remember that this side you have a conductor, which is a metal contact. On the other side, you have a metal contact, which is a conductor. So when you're widening the depletion region, remember why we call as a depletion region? That's a void, right? It's nothing in there. So depletion region will, if you increase the depletion region, it will increase as the plate separation. So does the capacitance will decreases. Does that make sense? So that's how we use a reverse bias Varactor diode to widen or narrow the depletion region in order to have higher or lower capacitance. If you increase the depletion region distance, the distance increases. If the distance increases, the capacitance will decreases. If you reduce the reverse voltage, then the depletion region will narrow. When the depletion region narrows, that means the capacitance will go up. So capacitance is always inversely related to the distance between the plates. Based upon what your applied reverse voltage is. So whatever the applied reverse voltage is, that's what decides how much depletion region you want, correct? So that's pretty much, it's heavily used in applications for radios, for tuning, AM, FM radios, communication circuits, heavily uses Varactor diodes, because if you remember, we talked about in 111, I think, concept of resonance. Anyone remember that? What is resonance means? So resonance is a condition that gives you highest voltage at a specific frequency. So in order to have a resonance circuit, you require an inductor and a capacitor. So if you change the capacitance, the resonance frequency will change. So highest voltage at a specific frequency. So here now, the change of capacitance is occurring by simply changing the voltage. That's a convenience. In olden days, television or radio receivers, when you're tuning a station, even now too, but definitely it's with the improvements of this Varactor diodes, it's convenient now in the design perspective. But in olden days on a radio receiver, if you're tuning a station, you are internally changing the capacitance of a capacitor. So that's a manual tuning. That's not a digital tuning. Nowadays you have a digital tuning where you push a button, it will automatically select a station for you. It scans everything, the whole range. It will play whichever the station has highest voltage, and it will play. For traditional radios, you manually need to tune it. But as you're tuning it, the dial is internally connected to multiple capacitors with a mechanical link. So all the capacitors with a mechanical link, like a chain, connected to the dial. If you remember potentiometers, like the variable resistors. So the problem with that technique is, since the linkage is a mechanical link, over the age, over the time, they may break. But now all the tuning is happening digitally. That means when you push a button, the voltage will be controlled, but internally the voltage controls the capacitance. So you don't directly control the capacitance. So now you can precisely control the capacitance, which can help you precisely tune a specific station. So that's a major application of this Varactor diode is in communication applications, receivers especially, AM, FM radios, traditional communications. So again, the idea behind this is make sure you have the diode reverse bias. Because if you have a diode reverse bias, you have a narrow or wider depletion region. So you can change the depletion region by changing the reverse voltage. So if you increase the reverse voltage, the depletion region widens. If the depletion region widens, the capacitance will decrease. If the depletion region narrows, the distance decreases. When the distance decreases, the capacitance will be increases. Right? So that's the behavior of the Varactor diode. So good. So that's another special type of diode that do exist.